Sorry for the some
No,
problem.
no,
No problem.
I think problem. So,
no, sir.
uh, so once again, thank you for giving me the opportunity to interact with the students, and I'm sure the students will be aware of this new technology, which is a non-thermal process, because most of the time we do use the thermal processing for the food preservation, and which is very common. Uh, Most of the processes as of today are all thermal processes, where means we are using the heat energy somewhere. Uh, I just would like to request, please put off your mics, because probably it might be problematic for others to listen. So the thermal processing is the process where we are using the heat energy to process the food. This processing is basically done to make the food palatable, or to preserve the food by the way of killing the microorganisms or inactivating the enzymes, or it is also being used to reduce the amount of water, so that we can lower down the water activity of a particular product, so that we can preserve the food for a long time. These are the basic things for which we generally prefer the heat treatment to the food product. But there is one added advantage of the heat treatment, is that sometimes the cooking also happens when we heat the food product, so that it becomes more palatable, more digestible. But it is not really required for in the all the products, but mostly our target for using the heat energy is to kill the microflora or to inactivate the enzymes. So the why the people are looking for the non-thermal process, the reason basically is there are certain disadvantages due to the heat processing, that is thermal processing, where there are changes in the texture, changes in the sensory attributes, changes in the heat sensitive ingredients do happen during the thermal processing. So ultimately, nutrition is a major concern, where the nutritional value of the food can be reduced because of the destruction of these components when we use the thermal processing. So to overcome these some of the challenges, non-thermal processes are being nowadays explored. One of the most important non-thermal process is high pressure processing, which is very commonly being used nowadays, where the high pressure can kill the microorganisms as well as it can inactivate the enzymes. Pulse electric field, ultrasound, and cold plasma are some of the other emerging trends. These are considered as a potential alternative to the thermal processes, because they are really worth trying for killing the microorganisms or inactivating the enzymes without destruction of the texture or without destruction of the heat sensitive ingredients. So non-thermal processes may overcome some of the challenges, definitely not all, but some of the challenges which we are facing during the thermal processing can be overcome by using the non-thermal processes. So cold plasma, which I am going to focus today, is one of the non-thermal process which can be easily used across the various sectors, including the agriculture processing, food processing, and even the bioprocessing. So to understand what is the plasma, cold plasma comes later, but before that, we should try to understand what is the plasma. Plasma is actually considered as a fourth state of matter, because we know there are three states of matter: liquid, solid, and gas, correct? solid, liquid, gas. These are the three states of matters. But whereas plasma has been considered as a fourth state of matter. Though plasma is nothing but the gas, which is ionized gas, but it doesn't obey the laws for the gases. Hence, these are not considered as a gases. And that's why these are being termed separately as a fourth state of matter. So when the plasma is generated, we can see that due to the ionization process, basically, we get the dissociation of all these gases into the different molecules like positive ions, negative ions, electrons, metastables, atoms, free radicals, photons, along with some of the reactive species. These are being, it is a composition of all the gases which is separated after the ionization. So if we see the plasma chemistry, ionization is the most important step in the plasma generation, because we cannot generate the plasma conditions unless we ionize the gas. So this plasma chemistry depends on the several factors such as feed gas, composition, humidity, power, voltage applied, and surrounding phases. Because usually, if we consider an air as a general gas which is commonly present around the in the environment, uh, which can be ionized very easily, because air is a mixture of various gases, and this mixture will give you the different composition of oxygen, hydrogen, nitrogen, carbon dioxide, carbon monoxide, and there are number of gases are there present in the air. So this air can be dissociated. The best example I can give you in a nature is the striking of the light in the sky, where when there is a such situation where the lights striking of the light, which is having the temperature more than 1800 degrees Celsius. So definitely at such a high temperature, whatever the surrounding air is there at that time get ionized very immediately because of the very high temperature. And that too under low pressure, or the means pressure may be lower than the atmospheric pressure, or sometimes it is, if it is far away, it may be almost the vacuum kind of thing in the atmosphere, and beyond the atmospheric stage. So considering all these things, if you can see, this is the basic point from where plasma has been considered and studied. So this ionization of air by the way of striking of the light is the major basis for developments on in the plasma technologies. So see, one another example is the sun. Sun is actually we know that it is a nuclear reactor basically. So it's an best example of the hot plasma. So the air around the sun is already ionized. All are the ionized gases are there surrounding to the sun, because, and that's why it is called as a hot plasma. But here now we can't use the hot plasma for the food processing, because then everything will be get burnt out and there will be no nothing will left except the ashes. So to overcome this we want to use the ionization of the gases, ionized gases, to make them useful for the food processing or the food systems, But therefore we don't want the very high temperature. We want the lower temperature. So considering that, it has been developed and tried to generate this kind of plasma in the laboratory, which is at the low temperature. Low temperature means most of the time it is at the room temperature, and therefore it is called as a cold plasma. See, the cold plasma doesn't mean that the temperature is sub-zero or something very low temperature. It's not like like that. Cold, because there is a hot plasma, which is the plasma which is present in the nature is a very hot in condition. That's why it has been called as a cold plasma. So whatever the ionization happens during the hot plasma, we are trying to happen the same kind of ionization at room temperature. And that's why this cold plasma is there, where we are trying to ionize the surrounding gases, for example, air, with the help of the voltage or the electric current. And that is why we are trying to have ionize these gases in the laboratory. So ionization of the natural gas at it gives you the neutral ground state atoms, molecules, or the radicals by electron impact is the most prominent ionization mechanisms by which you can definitely ionize the gases, maybe the neutral or ground state atoms, molecules, or radical which are being produced, or electron impact. The chemical composition of this air plasma is dominated usually by the ions like oxygen, nitrogen, nitrogen oxide, carbon dioxide. These are the different ions which are being produced during the ionization. So if you see the step by step, the basic principle in this is you need to apply the high voltage where the AC or DC electrical discharge, microwave, heat, light, magnetic field, or radio frequency. All these can be used to generate the high voltage in the system. And then most important is the feed gas. When you have all these high voltage, in presence of high voltage, you need to expose the feed gas, that may be the atmospheric air, that may be the purged gases like the pure gases like nitrogen, helium, argon, etc. Or combination of these gases can also be used depending on your requirement. So ultimately, these gases will be undergoing the ionization state, and that ionization will give you the plasma. So what is the plasma? Is actually the mixture of gas molecules, atoms, charged ions, free radicals, free electrons. Sometimes ozone is also developed if you are using the air as a carrier gas. Because of the oxygen, it will develop the ozone, elemental oxygen, and photons. This is the composition of the plasma. So this plasma will contain all these kind of different parts of the gases, I can say. Then this plasma have to be delivered in a particular mode, maybe the corona discharge or atmospheric plasma jet or pulse plasma or microplasma. There are different types of discharge or the delivery systems in the plasma. So in short, if you can see, I have tried to make it in a picture form where the cold plasma will give you the H2O2, nitrogen, oxygen, hydrogen ions. It also giving the ions per electrons. It also develop some of the heat radiations, visible light. It also develop the UV radiations during the plasma processing. So, looking at the working principle of the cold plasma, if you see here, we have the two electrodes. This is upper and this is a lower electrode. These are the two electrodes basically being, one is a grounded and other one is a with the electric supply. So these are the two electrodes, and in between the gap of these two electrodes, there will be the carrier gas moving into the gap of these two electrodes. And when these electrodes are being supplied with the electric current, the gases which are present here in between this gap of the two electrodes will get ionized. So material will be kept into these two electrodes. You have to keep the material into these two electrodes because your plasma is generated within these two electrodes. So when you want to expose the product to the plasma condition, your material should be within these two electrodes. Then through the gas inlet, gas or the mixture of gas will occupy the space, and the voltage, increase in voltage will definitely ionize the gas, and which will be it's an due to the ionization, you can have the different kind of species produced within that particular system. So here I can show you that in 2012, we at ICT have developed or designed this the plasma equipment, because see, in those days plasma technology was a very upcoming new technology, and even we were not having the instruments also available to do the research. So in those days, we have actually designed this kind of equipment in our laboratory by ourselves. So this is the top electrode and this is the ground electrode. So, so this is the bell jar kind of system where you are supposed to put the product in these two electrodes. And this, the glow which you see, pink color glow, is indication of the plasma generation. If the plasma is not generated, you can't see this glow. Then, considering this particular kind of system where you have to put the product between these two electrodes, what we have observed that the only the surface, above surface, the upper surface is being exposed to the plasma environment, whereas the product, when you keep in on this platform or the ground electrode, so that bottom of that particular product is not getting exposed to the plasma. So ultimately, only the surface is the above surface, which is open surface, is actually getting exposed to the plasma, whereas the at the bottom there is no exposure of the plasma. So to overcome this particular kind of problem, what we did is we have tried to develop the 360-degree rotating plasma generator. So here, actually, this is again the same design by us only, where we have tried to make this kind. This is actually the gas chamber, plasma chamber, which actually is rotating one. So at the both the end there are bearings. So now remember one thing is, this plasma which is generated here with the electricity, but at the same time there is some vacuum you have to apply to generate the plasma. So here, while developing this kind of thing, we have face a lot of problems, because when you put the bearings at the both the ends, it's very difficult to maintain the uh, vacuum in the particular zone, because this is a glass jar kind of thing, and to the both the ends there are ball bearings. So now we have got a special type of bearings for this, which we have used here, which can withstand with the little bit vacuum, so that we could generate the plasma inside this particular chamber. And that is the reason now, as this whole chamber is rotating in a 360 degrees, so all the sides of the grains particularly can be exposed to the plasma. This is the project which we have been funded by Ministry of Food Processing, and we could develop this kind of particular thing. Now, recently, last year, we have got a different another the plasma. Now there are some of the companies are there who are manufacturing the plasma equipments, and hence we got this particular equipment. It is again imported one, so that where you can see this power source and the pin reactor. So you can see this pink color is totally the plasma generated, and here also this is again the different kind of reactors where the plasma activated water can be developed. So here this plasma is generated into the water, and that water, because of this plasma, the properties of the water can be changed, and when you use this water, there are again the different advantages of this plasma activated water. I will speak in a later part. So overall, if you see the applications of the plasma can be used for the in the field of medicines, water treatment, polymer science, or food science, where in medicine, wound healing, sterilization, and dental plaques can be treated with the plasma. Nowadays, there are the dentists are having some torch kind of thing, uh, which can be used to remove the microbial load in the plaque which is found in the dental cavities. Because it is being a gaseous, it can occupy any kind of space. So wherever the shape and size is not the limitation for the plasma, because it is in gas, it is in the gaseous state, and that's why, being a gaseous in nature, it can occupy wherever the space is available. So it can treat that. Many times your toothbrush may not reach to that particular point, but the plasma can reach. That is the advantage. Water treatment. Here in water treatment, you can also use the hot plasma, because many of the effluent treatments can be effluents can be treated with the help of the hot plasma for decontamination or killing the microbial load in the drainage water. Then it may help in pesticide degradation and the degradation of dyes or pigments which are present in the effluents. In case of polymer science, it has been used for the surface modification of the polymers, surface functionalization, and sterilization. You see, actually we got this idea from the polymer science only, to use the plasma in the food processing. What happened? In the packaging, particularly when you are using the polymeric films as a packaging material, plasma is being commonly used. It is used. It is being commonly used there to modify the surface of the polymeric films. Why? What is the necessity to modify the surface of the polymeric film? It is all these polymeric films are having a very smooth surface, and when the you have to print something on this polymeric film, there is a problem that adhesion of ink was not proper. So this, how to overcome this problem is because the surface is so smooth that there is a not proper binding was there between surface of the polymeric film and the ink. So here one, I can give you one simple example. If you have most of you might be using the bicycles, and what you do when the bicycle get punctured, you will go to the person who can fix it. Okay. And then what he does when you take your bicycle to him, first he will remove the tube inside the tire, then he will put some air into that, and he will be having one small katora in which water is there. So he will just put that tube into water to check the location where the puncture is. So wherever the air bubbles come out, so he will come to know that this is the site where the puncture is. Because from that particular site air is leaking. Then what he does? He will remove all the air from the tube and he will point out that particular uh, spot, and he will start rubbing that tube with some rough surface. Okay. Why he is doing so? Because again, the rubber which is being used for the tube is again the smooth. And he want to patch up with some other patch on that particular point so that it can be sealed up, so that air will not be leaked out. So for the proper fixation, he will make both the surfaces rough, the tube as well as the patch which he is supposed to join there with the adhesive. So he will rub both the surfaces and make the surfaces rough, and those rough surfaces can be easily get patched up. So while patching up, you need the rough surface, and that is the reason in the polymers, these packaging material polymeric films are being usually the surface of these polymeric films is getting they are making it rough with the help of plasma, because see, the polymeric films are so thin you can't do it by mechanical way. So therefore what is being done is they are treated through the plasma atmosphere. So what does the plasma do? That is the major concern, is that the plasma actually makes the surface rough. How it does? Because it has some of the reactive species, it has some ions, atoms, some neutrons, protons, all these are electrons. So overall, when the air is being ionized, there is a dissociation of air happens, and all the molecules which are present there, which are bounded to each other in an homogeneous manner, they get separated from each other, and then that is actually known as a excited stage. So when the excited stage is there, all these neutrons, protons, and electrons are also in an excited stage, and because they are in excited stage, they will get attracted to the any kind of surface whichever comes in contact with them. And that is the reason in this process, all these unstable molecules will definitely try to get stabilized. And in a process of getting stabilization, they are actually scratch the surface, whatever comes into the picture. And that surface scratching happens when polymeric films are being exposed. These scratches are very, very minor scratches, very, you can't see by naked eyes. But scratches are there, and those fine scratches are helpful for adhering the ink properly. That is known as a surface modification, and that is the reason why we have adopted the cold plasma for food processing also, because we have tried with the brown rice. When we expose the brown rice to this polymeric to this cold plasma atmosphere, we could find that there also we can find the fine scratches on the surface of the rice grain, which helps in absorption of the more water within less time. So that is why we have tried to reduce the time required for the water absorption. Usually see the brown rice is hard to cook, it takes a longer time for the cooking as compared to normal rice because of the aileron layer which is present on the rice grain. So we are trying to break that aileron layer, or we want to have a fine scratches on that aileron layer, where that, because that is the layer which is actually responsible for uh, creating the limitation for absorption of the water. That is the hindrance. So we want to remove that hindrance, because see, you can remove it by the way of polishing. But again, when you do the polishing, the nutritive value of rice will go down. But brown rice will have the more nutritive value as compared to polished rice. That is what people says. And that's what the brown rice is more nutritious as compared to the white rice. That's what we have targeted, the brown rice, so that due to the cold plasma, there will be no change in the other constituents, because there is no heating, nothing. It is just an making some of the surface catching, surface itching, so that you can increase the water absorption. Once the water absorption is increased, probably the um, cooking time can be reduced, and that's what we have observed. So here, when using for the foods, we can also use the cold plasma for the food systems, where you can scratch the surface by the way of using cold plasma, and you can increase the water absorption and other things. At the same time, decontamination of the any product can also be possible, because most of the organisms are present on the surfaces, and these surfaces can be easily decontaminated. Uh, some of the organisms which are responsible for the mycotoxin production can also be killed. Enzymes can be inactivated, and even the degradation of pesticide residues is also reported with the cold plasma. So these are in case of food and agriculture. You can see we can use the plasma in cereal and pulse industry, fruit and vegetable, dairy industry, meat and poultry, spice industry, even the biopolymers and agricultures. These are the some of the few examples, but there are many more also. So we were recently worked on the one Indo-Sri Lanka project, where we have tried the cold plasma treatment for decontamination of the spices, because spices are mostly contaminated because of the fungal growth and all on their surface. So it can be really controlled by the use of cold plasma. So in case of surface modification, actually it acts on the surface and have a limited penetration power. But plasma is known as a surface modification, is known for the surface modification, where the surface morphology can be changed by the way of scratching or itching. And maybe probably due to that, you can see that there is an increase in the hydrophilicity of the material. So plasma can also be important for changing or altering the hydrophobicity to the hydrophilicity. The hydrophobic product, limited hydrophobicity, can be turned into quite hydrophilic products. So there is a increase in the hydrophilicity of the material. In case of microorganisms, it is due to the deformation and leakage of the microbial genetic materials. Lipid oxidation can usually, particularly the cell membranes which are composed of the lipids. So this lipid oxidation also can kill the cells, microbial cells. Cell wall rupture, that is due to electrostatic forces like electroporations and protein denaturation, oxidation of amino acids and nucleic acids, can also be achieved by the way of using the cold plasma mechanisms. This is a general mechanism for the inactivation of the microorganisms, where the what I have explained right now is that is the thing, that where there are the different active components. There are radicals, free radicals, UV radiations, charged particles and all, which are generated because of plasma, and then they directly attack on the surface, the membrane of the microbial cells. This is in case of the inactivation of bacteria. You can see we know that there are two types of bacteria, gram positive and gram negative. The action on the plasma on the gram positive and gram negative is totally different. So in where the gram negative bacteria are there is a permanent rupture on the membrane can be possible, but whereas gram positive bacteria, probably membrane will not get be ruptured, but at the same time there is a chances for the leakage, small leakage from the membrane, as well as the destruction or the alteration of the DNA component in the cell. This is for the fungus. Again, plasma is quite helpful in inactivation of the fungus. Plasma can also be used as a green mutagenic agents where physical mutagens, chemical mutagens are being commonly used. They are having certain limitations, but whereas cold plasma can be alternative to for these mutagenic activities where clean plasma is a clean source. It is targeted action through the carrier gas, means you can use the particular gas to target something, or byproduct generation. There is no byproduct generation and there is no risk for the person who is handling all this. Whereas in case of chemical mutagenic, sometimes the uh, product may be the carcinogenic and probably it may be the toxic also. So these are not the things with the cold plasma. Enzyme inactivation is also possible because of the changes in the alpha helix and beta sheets in the protein structure or the amino acid structures, and that actually can be responsible for inactivation of the enzymes by the use of cold plasma. So upgradation, downgradation of specific enzymes and all, these are some of the important parameters where the plasma can be used effectively. Uh, there are many research papers nowadays available on the plasma processing. Even the people have used the plasma for improved production of the glucose and conversion of the glucose to the ethanol in the Saccharomyces cerevisiae and all. Wherever the fermentation kind of fermentation is there, there also plasma can be used to enhance the ethanol production, and maybe the increase in the free calcium content in the microbial cells, and there are many advantages of this. Lactic acid production also can be increased by the way of using the cold plasma in the distillery stillages. Then treatments in the batch results in the wine processing also to develop and to get the better color, better aroma. Plasma is also being used for the red wines. So this is the atmospheric pressure cold plasma which can be used for the wine making industry. This is an illustration of the earlier figure where here, this is the plasma flow and this is a wine, so that at the junction, at the surface, this wine can be treated with the cold plasma. And the another way, this is a batch type of process, but when you go for the continuous process, it is also again like this. The plasma generation is being done here at where the green, you can see the blue green color, and the pink color here is the wine. So wine is get in contact with the plasma atmosphere at this particular zone, and then it has been coming to the tank. So here, due to this, it has been claimed that there is an increase in the polyphenols in the wine that has been done. So even it can be used for the black tea and green tea. We know that black tea is a fermented one, green tea is non unfermented. There also they have used the plasma to kill the microbial cells, and at the same time it has been also seen that there is an increase in the phenolic compounds in these teas. So total phenolic content was slightly increased after 5 minutes of the plasma treatment. So these are the some of the techniques where the direct exposure of the contaminated surface to the atmospheric cold plasma can definitely kill the microorganisms. Even the viruses also can be killed uh, with the help of cold plasma. These are the some of the examples for the continuous deactivation at the atmospheric cold plasma. So this is the chamber where the cold, you can see this pink color, which is the plasma generated in this particular chamber, and the product is being passed through that plasma atmosphere. That is a tunnel, and which can definitely kill the surface microbial load. So, I just would like to conclude here that plasma is an emerging technology for surface decontamination of the food, packaging material, biofilms, and even the other materials. The effect of cold plasma on microorganisms and the enzyme need to be better understood, because still studies are going on and people are trying to understand in a better manner to use the cold plasma effectively, particularly the reactive species which are generated during the cold plasma. And then this must be the effective tool for various food and bioprocessing operations. So with this, thank you very much for listening the presentations. And if there are any questions, I'm happy to discuss with you.
Hello.
Hello.
Yeah. Subda. Hello.
Hello, sir. So I am taking the charge due to some technical
Okay.
issues.
Yeah.
Yes, sir.
Go ahead.
Yes.
Go ahead.
Thank you. Yes, sir. Thank you, Professor Uday, for all those enlightening words on cold plasma. I know that it is a very revolutionary technique in food industry. After that, I would like to request all the participants that please feel to interact and ask questions in the chat box, but keep your audio turned off. If you have any questions, please put them in the chat box. So I guess there are no questions. So can I proceed?
No.
Okay, no
No.
problem.
What you do, Ruchita? Ruchita,
Yeah, if
direct
they want
let
to ask, they
yeah
can ask instead of in
yeah
the chat.
let them unmute the microphone and
Huh.
directly can ask also.
All right,
But
no
don't
problem.
unmute
Actually,
many people together. They can
Yeah.
unmute one by
Yeah.
one. That
Yeah.
will be better.
Yeah. I could see one question has come, Ruchita.
yes, sir. Yes, sir.
Just one question has come in chat box. Just read that.
Yes, sir. So this is a question by Prateek Patil. How cold plasma techniques are helpful in preservation of meat and fish?
Yeah, see, particularly in case of fish, I can say that most of the time it is coming from the water, and there are chances that it is highly contaminated with the E. coli. And definitely the cold plasma treatment is very successful. People have already work in this area, uh, that decontamination of the fishes by using the cold plasma. So recently we have prepared one review article in the this particularly focus on the fish processing, application of the cold plasma in the fish processing, and where we could see the lot many research papers where the cold plasma is being used to kill the E. coli particularly. And in case of meat also, the meat is basically contaminated by the way of salmonella and all. So salmonella also can be killed when it is the meat is exposed to the cold plasma atmosphere. So basically, microbial inactivation in meat and fish can be definitely achieved by the cold plasma. Okay, I think I have answered the question.
Yeah. There is one more question, Ruchita.
Yeah, I can see that. Shivani has
Madam.
asked that you told that if plasma is generated, we can see the pink glow. Is it the property of it, like special property? Or yes, yes, it is a property of the plasma. When the plasma is generated, you can see the pink color. See, this pink color is nothing but actually there during the plasma condition, there is generation of the UV rays also, and that is the reason you can see this glow. It is a combination of the UV rays and some other ozone and all together. It gives you the pink color. That is the speciality of the plasma. Definitely, whenever the plasma is generation, you will always see the pink color. That is a it's a range actually pink to violet, so it generally either dark pink, which is close to the violet, like that. That color is always there. That is a typical signal. It is a property of the plasma.
I hope your
Hope I
question
have,
is answered, Shivani.
yeah.
Are there any other
Yes,
questions?
sir. Thank you, sir.
Are there any other questions? If you want, you can unmute your audio.
One more. Ruchita, one question has come. Just read in the chat box.
Yes, sir, I'll read the question out. This is a question
Yeah.
by Apeksha Jadhav. Due to presence of UV light, did it cause any harmful effect?
No. See, UV generated here will definitely will not have the harmful effect on the product, because anyway we are using the UV very commonly to kill the microflora. So we generally use the UV treatment for the water for killing the microflora. UV treatment, it is a drinking water. It's very common that we are using the UV treatment. Apart from that, UV is also being commonly used to as a disinfection, disinfecting the surface area. Basically, it is a surface sterilization. I think 2 3 months back, I have read one article from, I think in from Kolhapur area only. Someone has developed and one UV cabinet which is used for killing the corona also. So, and that they have prepared the UV chamber, and that
Yeah.
UV chamber is actually where you are passing the fruits and vegetable into that. The definitely, because that also in 2010, I have worked on that when I was in Washington State University. That time we have done those experiments, UV treatment for apple and pears for the surface sterilization. And definitely we got a good success into that. We have published that. Somehow the same has been actually that newspaper have mentioned that our work there, and based on that they have developed this UV chamber where you can kill the micro surface microflora on the fruits and vegetables. So they, of course, they were again, but that is proven. It can be killed by the help of UV, but again, further they have gone ahead and they have claimed that corona also can be killed. I'm not sure about that, but maybe they might have be having some this kind of results with them.
Yes,
So
sir.
UV light is basically not harmful for the food product as such, but it is harmful for the microorganism. That is true.
Thank you, sir.
So,
Sir, Manish,
yeah.
yes, sir. Manish from Food Processing, he has written that, sir, our traditional food education in different degree courses is favorable for Indian food industry.
I didn't get what Manish what exactly want to ask.
Manish,
Manish,
please.
you can unmute. You can unmute and ask directly, Manish.
Our traditional food education in different degree courses is favorable for the Indian food industry. Actually speaking, it is not favorable for the Indian food industry. Whatever the food technology usually we being taught in different colleges and course curriculum is basically developed is based on the foreign products. We use the bread, biscuits, and all. Those are actually the foreign products. But that is those are the products where the food technology has been developed and taken to the industrial scale. But still, there is a lot of scope to work on the Indian traditional food products which are not being taken up to the industrial scales. Now people have started on that. I could see the various equipments and all which are circulated on the WhatsApp, that jalebi making machine, imrati making machine.
Chapli.
Now we have come up with the chapati making machine. So slowly we are coming into those sectors, but really it needs a very good engineering to develop such kind of equipment and machineries. That is more important, and that is actually need of the hour. But but the problem is that the traditional food, Indian traditional foods are very complicated, and to develop the equipment or machinery is the real challenge for the Indian food industries. And secondly, the taste of the Indian people is not a constant. If you see, when you all over US, wherever you go, wherever you travel, you will get the same taste of the McDonald burger. But in India, we can eat such products for some time, but not all the time. Therefore, we need the change. And to make the change, it is very important to look into that particular factor, that what can change and what is the requirement of the people to change. I will give you an example. Uh, Lay's. Lay's from the Pepsi is a #1 brand in the potato chips. Okay. You can see these Lay's across the India or even across the whole world. But if you really look at the things, the taste of the Lay's is different at different location. Maharashtra, the taste will be different. At Gujarat taste will be different. If the Lays are being sold in Kerala, the taste will be different. That is the reason. That is the reason why Lays is #1. If you have a same product without variations, local variations, your product will not be accepted. The product which has been liked by the Maharashtrian people may not be liked by the Keralites, or may not be liked by the Gujarati people, because their taste is different. So you have to see that while doing the while working in the traditional food, you also need to set the particular taste for the particular region. Then your product can be very easily accepted by pan India. That is the reason. Anything else?
तो क्या
Could
ना
I ask you
कैमरा ना
your-
कैमरा आपको
मैं नीचे कैप्शन ऑन किया था, आपको नहीं दिख रही थी। इसको
Yes, sir. Thank you, sir. So there is another question by Mayuri Pawar.
क्लिक करो
cold plasma treatment is used or
ठीक है,
ये निकालो
for all type of food
जो
groups.
नीचे कैप्शन वाला दिख रहा था,
हाँ,
आपको दिख रहा है कि नहीं?
See, cold plasma is actually being used as a surface treatment. So wherever you want to kill the microflora on the surface of any kind of material, you can use it. Again, if this cold plasma, if you want to use for enzyme inactivation, then there are different limitations. So though this is a new technology, but it has its own limitations also, because plasma will not have the penetrative power same as UV. So it will work only on the surface. So you need to expose the material whatever is possible way. But another case is that the surface which has been exposed to the plasma atmosphere will definitely create a small scratches or itching or something like that. So whenever you want any kind of material, probably the surface modification can be possible in the plasma.
South sir, please turn off your audio. Your audio is on, South sir.
Anything else?
Yes, sir. There's another comment by Shivani. Is it cost effective that the thermal processing, because for the industrial level, one will see for the cost effective technique. So is it cost effective?
So as of today, I can't say that it is a cost effective, but definitely in the future it may be the cost effective, because at this moment it has not been grown at that industrial scale. At till time we are working at the laboratory scale, so probably cost will be more. But once it can be scaled up, probably cost should not be the issue.
Yes, sir. That's all, sir. Thank you for all those enriching words, sir. Now I would like to ask my friend Rahul to please express the vote of thanks.
Ruchita, I would like to take over.
Yes, Suraj. Yes, Suraj.
Thank you, sir. Finally, I would like to take and privilege to place on a record vote of thanks to the head of Food Engineering and Technology, ICT, Professor Dr. Uday Annapure, sir, for your valuable guidance and time that you shared with us. Sir, thanks for sharing your valuable knowledge and thoughts about cold plasma novel, non-thermal food processing and its possible applications in food processing sector. I take this opportunity to thank Director of Department of Technology, Professor Dr. J.S. Bagi, sir, for presiding for today's inaugural function. Now, I would extend my thankfulness to Dr. A.K. Sahu, sir, Head of Food Technology Program, for organizing today's event very meticulously. I would also like to thank today's event coordinator, Dr. I.S. Uchan, sir, and all the faculty members of Food Technology, as the committee members, including Dr. S. Lokhande, sir, Dr. D.V. Mote, sir, and the teamwork working behind the screen, which kept us connected by the digital media. I would also like to thank participants who are from every part of our country for actively participating and making the program grand success. I would also like to thank the members who directly or indirectly participated and supported us to make this program success. Now, I would like to declare that the inauguration session and the first technical lecture is over. Thank you, sir.
Thank you. Thank you.
Yeah. We'll join for the next session at 1 p.m. Thanks, everyone.
Yes, sir. Yes, sir.
Thank you. Thank you, sir.
Thank you, sir. Thank you. Bye-bye.
Bye-bye.
After 15 minutes, one more time, we will send the links. Then all of you can join the link for the next lecture. Thank you.